Okay, in this video we're going to talk about simplifying some exercises by using rules of exponents. So we're not specifying if it's the product rule, the power rule, or the quotient rule. We can use any of them, maybe more than one of them on the same exercise. So for the first one we have m to the 12th, n to the 13th, n to the third, I'm sorry. So it should be n to the third power over m to the fourth times n, and then everything to the fourth power. So now on this one, what I want to do is first I want you guys to think about PEMDAS again, which was parentheses, exponents, multiplication, division, addition, and subtraction. So the easier way to simplify this is by working with or simplifying whatever it's inside of the parentheses. So we can begin by applying the quotient rule, right, to our fraction inside. And we do that by grouping the numerator that has the same base with the part of the denominator, and then grouping those two. So in this case we have m to the 12th over m to the 4th, and then times n to the 3rd over n. So this is going to give us m to the 12 minus 4, and then times n to the 3 minus 1. Let's keep in mind there's an invisible 1 right there. And then everything is to the 4th power. So this is going to give us m to the 8th times n to the 2nd power, and then to the 4th. And now that 4 outside will be distributed to the exponents inside, which is going to give us m to the 32 times n to the 8th power. So we had a combination of quotient rule and then the power rule. Now let's just try another one. For this one we have 9 over 54, or I mean 9 x to the 4th y negative 5 over 54 x to the 3rd, and then y. And then we're going to have a negative 2. So we want to do the same thing. First apply the quotient rule, right? And then see where and what we can do from there. So we can see that we have a 9 over 54. Those are numerical values, right? And then x to the 4th times x to the 3rd. And then we have y negative 5 times y to the 1st power. So for the first one we have 9 over 54. Now this can be reduced by 9, right? Both. Then for the second part we have x to the 4 minus 3. And then for the last part we have y negative 5 minus 1, because again there's an invisible 1 on the exponent of the y in the bottom. And then to the negative 2. So I can tell that our first fraction is going to become 1 over 6 times x to the 1st power, and then y to the negative 6, and then to the negative 2. Now what's going to happen is that this negative 2 outside will get distributed into all parts of the term of the expression. So we are gonna have 1 over 6 to the negative 2 times x to the negative 2 times y negative 6 to the negative 2. So because we know that this is a negative exponent, 1 over 6 will become 6 over 1 to the 2nd power. And then this x to the negative 2 will become 1 over x to the 2nd power. And then here we can multiply negative 6 times negative 2, so that will be y to the positive 12. Okay. So from here we have 6 to the second power, that will be 36. And then over 1 to the second power, which is 1. And then times 1 over x to the second power. And then times y to the 12th power. So notice how when I had negative 6 and negative 2, I pretty much just multiplied those two. And the reason I did that is because that negative 6, I noticed it could change to a positive exponent. So at the end, this will give us 36 times 1, because 1 to the second power is actually 1, so it will be 36 y to the 12th over x to the second power. So again, it's like we have a 1 and then a 1, so the only three terms that we have on the denominator is 1 times x squared times 1, which is x squared, and then 36 times 1 squared times y squared.